Before we examine how we deal with discrete probability distributions using our TI and SPIRE, let's have a quick look at how we would manually find the mean, variance and standard deviations. We have a legitimate probability distribution demonstrated in this Excel spreadsheet where we have our X values and the probability that X occurs. We know that it's a probability distribution, or that it's a valid probability distribution, because the probabilities add up to 1. In this third column, we've got our X values and multiply them by the probability of X occurring, and then we fill those results down. The value down here is the sum of X times the probability of X. The fourth column, we have X minus the mean. And if we recall, the mean is the sum of X times the probability of X occurring, so it's 225. In order to complete this column, it's X minus the mean of 225, and we fill our column down for each of our X values. Then we square them, so we're squaring all the deviations, and that's just the total of the deviations. And then we multiply the probability of X times the deviations squared. Then we complete this column. And that will end up in this result here. So that result is the variance, the sum of X times the mean squared times the probability of X occurring, and that is equal to 4,375. The standard deviation is the square root of this particular value. Now that's not the only way that we can calculate variance. The other way we can calculate variance is by finding the expected value of X squared. So we'll grab our X values and square each one of them, and then multiply them by the probability of that occurring. So that's 100 squared times 0.05 in our first column. Then in our second row, we have 150 squared times 0.15, which gives us 3,375, and so on. And we add all of those totals. So as I said, the second formula for variance is equal to the expected value of X squared, which in this case we've evaluated to 55,000, minus the mean squared. The mean is 225, so 55,000 minus 225 squared, which will result in 4,375. So we have two possible ways of calculating the variance.